Hello everyone and welcome to the Esri GeoDev webinar series. We started this series as a way to continue engaging in developer-related topics and discussions in between dev summits. Speaking of which, we have our next developer summit coming up in Berlin next week. We have a lot of new topics, advanced features, and additional functionality to share with you over the next coming months. So be sure to stay connected with us through our GeoDev webinar series page on go.esri.com/geodev or any of our social media accounts at Esri GeoDev. We would love to have conversations like these taking place throughout the year so that when we do meet at a Dev Summit conference, it will be as though we never stopped. We hope you get as much or more out of this webinar than you anticipated. Now we would like to introduce you to today's webinar, Building Offline Location-Based Apps with the ArcGIS Runtime SDKs. Before we get started, I'd like to go over a few items so that you know how to participate in today's event. We've taken a screenshot of an example of the attendee interface. You should see something that looks very similar to this on your own computer desktop in the upper right-hand corner. You're listening in using your computer's speaker system by default. If you would prefer to join over the phone, just select Use Telephone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. I would now like to introduce you to today's presenter, Nicholas Furness with Esri.
Hi, everyone. So thanks, Amy. My name is Nick Furness. I'm product manager for the ArcGIS Runtime SDKs. I focus a lot on iOS in particular, on the iOS SDK. And so a lot of the code samples you'll see today, in fact, all the code samples you'll see today will be written in Swift. I don't expect you to understand Swift. They'll be pretty easy to follow along and understand. As we go through today's presentation, you'll see a little footnote mark in places. Unless you see that symbol, everything you'll see me covering today can be done for free with the light runtime license. I just want to mention that up front. A lot of people have questions about what you can do offline, at which license levels and what it's going to cost you. So the good news is tremendous amount can be done without any cost whatsoever. So let's jump right in and start to talk about what it takes to build an offline application using the runtime. So in the ArcGIS world, runtime is the way to build offline applications. The JavaScript API is great for connected apps. Runtime is also good for connected apps, but it's the only component of the platform where we developer component of the platform where we actually support well-defined offline workflows. And as you build your application, you need to understand a few questions and answer them. Understand whether your app is going to be connected all the time or whether it's never going to see a network. It's quite possible it will never see a network depending on your use case. And there's this area in between as well where you might sometimes see a network, and depends on the network connectivity. You might have great network connectivity a lot of the time, and then you get areas of your infrastructure where you don't have good network connectivity. And so you need to think about that as you design your application from the start. Are your users going to be viewing data, or is there going to be a need to actually edit the data while it's offline? Or even if you're in this sometimes scenario where you might be online, might be offline. You also need to consider scalability. So you've got data in your map and services that you want to take offline in your applications. How often is that data updated on the back end? How often is it updated on the applications? And how many users are you going to be deploying this application to? So all these things feed into this decision on how to design your app for offline. Think about these up front. And over the rest of this session, we'll talk about the approaches Runtime provides to take the answers to these questions and figure out how your application is going to work. So the ArcGIS approach to building offline apps revolves around maps. Now, this may be a refresher for a lot of people. This may seem very simple, but it's important to set the groundwork here. Maps, when we talk about them, mean web maps or desktop maps, either in ArcGIS Online or ArcGIS Pro. From the runtime perspective, we translate these things into mobile maps. And actually, these mobile maps come in something called a mobile map package. We'll talk about that over the next few minutes. So just as a refresher, what is a map? Well, it's a list of ordered layers. You start off with a base map. It's your reference. On top of that, you overlay your data, your operational data, we call it. Could be feature layers, pulling in individual records from databases, points, lines, polygons that are drawn on the client. Could be tiled layers, imagery, satellite imagery. Could be individual rasters and so on. A map also includes rules about symbology and labeling. What do these features look like when they're on your map? It's just a polygon, but according to its attribution, how should it be displayed? Should it have a thicker border, thinner border? Should it be filled? Things like that. And then the labeling rules. How exactly should we mention attribution on the map? Station names, for example, if you drop a layer of stations on your map. The map also includes pop-up definitions, so that you as an author of a map can define how, when somebody taps on one of these features in your map, they get to interact with it. What pops up in terms of attribute lists? Is it a list of attributes? Maybe it's a graph. Maybe it's a bit of text that talks about it and has specific attribution included. Perhaps it includes an image. And a map also includes things like an initial view, bookmarks, and much more that help other people take your map, which includes all these layers, and work with it. So I'm going to jump into a demo right now, and we'll look at creating a map and then opening it in the runtime. Okay, so here we are at my organization's homepage, and we're just going to create a new map. I'm going to add some data to this map. Let's search for some layers. Just so happens I've got some Palm Springs locations conveniently at the top there, and I just want to change the initial view of this map. I'm not very happy with that full extent. Okay, so I've got my locations on the map. I want to do a couple of things here real quick. First thing, I know there's a type field on here, so I want to symbolize these based off type. You can see now it's broken them down. It's analyzed the data behind it and come up with a classification. I also want to make these symbols just a little bit bigger so they're a little easier to see. That should do. And one last thing, I'm going to change the base map from the topographic to something a little flatter. Okay, so now my locations stand out. I'm going to save the symbology, and we've got this map. So I'm going to save the map now. I'm going to call it Palm Springs Locations. Got to give it a tag. And then for the sake of this demo, I'm going to share this publicly. That means in the demo code, I'm not going to have to worry about credentials and authentication. Okay, so now up the top here, you'll see this URL now has this ID on it. So once we saved it, it got this identifier. We could also go ahead and look at the details page for this map. And this you might be familiar with. And again, this ID is sitting at the top. So I'm going to copy this ID. And we're going to jump over to Xcode. So here I've got a project that's going to open this web map in a map view. First thing I do is connect to the portal. In this case, I'm connecting to ArcGIS Online. Then I create a portal item using that portal as a reference, and here's where I paste in that ID. So between the portal and the ID, the runtime knows how to get hold of that web map. Then I'm just going to create a local map using that item and display it in the map view. So when I run this, we can see that web map displayed in the iPad, exactly as we configured it, the same base map, the same symbology defined, and as we zoom in and navigate, you can see those vector tiles working to give us all the high detail we expect from them. Okay, so that was a refresher really. We saw creating an online web map and opening that in the runtime. We saw how simple that was. And we can see that reflected here. Create a portal, create a map from the portal item off that portal, and just associate that map with the map view. The runtime takes care of everything else in terms of displaying that. So let's compare web maps with desktop maps very quickly. The web map we just saw is always connected. Data comes from services. You can view and edit that because you've always got a connection to this data, and it supports many users. You just give them a URL and they jump to it. With the desktop map in ArcGIS Pro, you can be disconnected or connected depending on where your data lives. You can point at services or have data on your drive or on network shares. You can view and edit that data, and it also supports many users. The difference comes into how you distribute that map. With a web map, it's always current. Anyone pointing at that URL refreshes their browser and they see the latest version of the map. If you change the symbology, you change those pop-ups, you change the layers that are in it. In ArcGIS Pro, you have to understand how to distribute that map. It's a Pro package maybe, and you have to send a new Pro package out, or it's sitting on a share or something. There are various ways to make this easier or harder depending on your connectivity. Mobile map package is derived from these kind of maps. So web maps and desktop maps can be used to create this thing called a mobile map package. A mobile map package contains maps that the runtime can work with. In desktop, you use ArcGIS Pro to publish a mobile map package. When you're working on the web, you point the runtime at a web map, and runtime creates essentially a mobile map package on the device, but you never really get to see that. It's all hidden behind an API. And we'll see these APIs in action in a second here. So let's start off with a desktop map and what it takes to turn that into a mobile map package. So the desktop map can be disconnected or connected. The mobile map package that's derived from it is disconnected purely. As a result, it can only view data. So that your desktop map's data will be packaged up into the mobile map package, and it becomes a read-only experience in the runtime. You have to understand what you're going to do when your data updates or when your map changes. You probably have to repackage that and create a new mobile map package and understand how to distribute that to your applications and your users. But both, they both support many users. That mobile map package can be used by many, many folks. The desktop approach also includes getting directions and geocoding. You can package that up as part of the mobile map package, and so do offline directions and offline geocoding, forward and reverse geocoding directly on the device. And of course, because it's directly on the device, it's very fast. You'll notice that little footnote mark isn't here. You can do this on the light license at no cost. If you've got Pro to generate the MMPKs, or someone gives you an MMPK with these things in them, you can use them. Just to summarize again, this is read-only. You create it once, sideload the MMPK to devices. When the data or the map changes, you need to re-sideload that. So we'll jump into a demo and take a look at what that looks like. So I want to take a quick look at generating mobile map packages. You can do that in Pro. You generate an MMPK file, you then have to sideload onto your device. Here I've got a Pro project that has a couple of maps in it. So looking at the same data, just different views in the same project. And if I just want to export the current map as an MMPK, I can pick the map, I'll go Share, and use the Mobile Map Package tool. This is now going to create, you see it says Share the Stormwater map, that's this map here, as a mobile map package. It's going to create an MMPK of just this map. I'll give it a location, specify a little bit of stuff about what I want included in here, how I want to clip the data. Maybe I've got a polygon layer that will define an area of interest for me, and I can package that up. Clicking Package will generate an MMPK. But MMPKs are mobile map packages, so they can include more than one map. And let's say I wanted to create one that had both the overview and the stormwater map in it. Well, in that case, I go to the GP tool, and I look for the Create Mobile Map Package tool. You can search for it. It just happens to be in my history here. So I'm going to fire this up. And when it shows up, we'll have a few options. This is very similar to the other tool, only now we get the opportunity to select from a number of different map definitions that we have defined in our project. Still specify the MMPK location, and there's a little more information here. Since we've now got multiple maps in there, we can say I want to export the data covered by the union of those map areas. And then I'll just go ahead and run that. That generates one MMPK with multiple maps, but just one set of data that all those maps make use of. So let's take a single map MMPK and look at what that looks like on an iPad. So here I've got Dropbox with an MMPK, and I've written a runtime application that knows how to open MMPKs. I'm going to tell Dropbox to just open it in that application. And that MMPK is now opened up by runtime. I can zoom in. We see all the feature details. We got the base maps. We can navigate around. It's all drawn directly on the device. So let's take a look at the code required to open that. It's really very simple. When iOS called in from Dropbox to say I've got this URL, this file at this URL, here's that URL. I go ahead, I create a mobile map package from that URL. I load that mobile map package to understand what's contained within it in terms of the maps. And I get the first map out of it, and I just apply it to the app's map view. That's all it takes to display that map from the mobile map package in the map view on the iPad and make it fully interactive. Okay, so just a quick summary there. We've got a mobile map package on the device. There's a file URL, a local URL in the file system to that mobile map package. We create a mobile map package object from it, load it so that we can understand its contents, and then get its first map and apply it, set it to the map views map. It's very simple. If you remember from the first demo, we pointed to a portal item to get the map. In this case, we're just digging into that mobile map package to get the map. And in both cases, we just set it on the map view. So let's take a look at how we turn web maps into mobile maps. We just saw how we turn desktop maps into mobile maps. With a web map, it's always connected. You can view and edit. The content is dynamic. As whenever anyone visits the URL, refreshes it, they see the latest version. In a mobile map, we want this to be disconnected, of course, but we can still view and edit. And the reason for this is that we can go ahead and contain or retain pointers back to the original source data that we're pulling the mobile map down from. And as we make changes periodically, when we've got network connectivity, we can talk back to those original services and push those changes back up, and as well pull changes down from them. We'll see that in that operation later. Now, how you do that and handle these updates, either pushing up or pulling down or both, involves a little bit of thinking about how you want to do that. And this ties back into those initial questions about scalability, how many users are you going to be supporting, and so on. And we'll talk about the strategies that we support with Runtime to do this. You'll notice I've marked edit here as not being part of the light license. If your data is completely public and has no authentication, you can actually do editing online and offline with a light license. But most people want to have some authentication over their data. They don't want it wide open. And for editing online and offline with data that isn't completely public, you do need a basic license or higher. Okay, so how do we turn a web map into a mobile map? Well, there's a couple of ways. We can create it as needed by each user. They're sitting there looking at their connected map and they're like, hey, I want to take this area I'm looking at offline. Set it up for me and download it to my device. Runtime allows you to do that. There's great flexibility. You don't need to think ahead of where you're going to be, but it does place load on the server, because when you decide you want to take the map offline, the server has to do the work to package it up and get it ready for you before the runtime downloads it. Another strategy is to think ahead and know, oh, my users are going to be in these predefined areas. Let's create a package, a mobile map for each of these areas, and just have it available to download to many users. That way it's created once and can be downloaded multiple times. Superb for scalability, but it does require a little bit of planning. We call these two approaches OnDemand and PrePlanned, and you'll see these in action over the rest of this webinar. So we'll start with looking at OnDemand, and I'll jump into another demo now to demonstrate this. So let's take a look at the OnDemand workflow. The OnDemand workflow and the PrePlanned workflow, for that matter, both begin with a web map. Whether you author that web map in ArcGIS Online or Enterprise, or in Pro and publish it up, the web map is central. So here we have a web map with a few layers in it. We jump over to the settings and take a look at the offline settings and see that there's this Enable Offline Mode checkbox. If that's on, you can take your web map offline as a whole. You may need to make sure that individual layers are also enabled for offline mode, but by and large, you should be good to go. So let's take a look at what taking this web map offline looks like from an iPad. Here we've got that same web map, and I'm going to navigate around. We're currently looking at the online version of it. I'm just going to take a portion of it offline. Now, Runtime is talking to the server at this point, to ArcGIS Online or ArcGIS Enterprise, and kicking off a number of jobs on the server side to generate the components that Runtime needs to be able to use this map offline. Here we're pulling together some base maps and some feature services in the form of offline geodatabases. And we'll pull those down to the device and use them to display the data. Now, in addition, ArcGIS Online and Enterprise will pull together metadata about the map, information about layer visibility scales, pop-up overrides, bookmarks, and so on. And that gets pulled down as well, and all hydrated and used together by the runtime to create a full offline map experience. So it looks like right here, We've got the geodatabase down already. We're just waiting for these vector tiles to finish generating and download. Once that's happened, you see the download happens really quickly and we have a fully interactive offline map. Now what you'll notice here is that some of the features extend beyond the extent of the base map that we were interested in. That's because by default, the map will get complete features down. We don't clip anything. That's important if you're doing editing. So the offline map task allows us to override settings for specific layers if we need to. So what we could also do is we could get rid of this, and we can pull this down with a larger base map area. So again, this is kicking off a similar kind of process as before. In fact, it's exactly the same process, but the parameters for the base map only have been overridden to get a much larger area. We'll look at that code in a bit and compare the code with the overrides and the code without the overrides. So we can see we've got the geodatabase already. We're just, again, waiting for those vector tiles to be generated. Okay, so now you can see that's the extent of the features that we were interested in. You can see some of them extend way beyond that. Only this time we've managed to get a base map that's larger and can cover the area. So what's happening in code here when we do this? So we begin by opening a web map in the application. We do that a lot like we did for working with an online map. Give it a portal ID, portal, and we create a map from it. Again, we're opening that in the map view, but we're also in this case creating an offline map task based off that online map. Then when we click the download button, we generate an area of interest that we want to get. That was on the iPad, that was shown as the red outline. We take the offline task and we generate a set of default parameters considering that area of interest. Once we get that back, we can just say download the on-demand area using the offline task with those parameters. We can specify a location on the local device where we want to keep that offline map. That kicks off this download on-demand area function here. We're just going to set up some UI for the progress bars. We're going to create a job. Here we take the offline task again. We say generate an offline map job using those parameters to download to that download location. We're going to hook up some progress bar observation stuff to keep the progress bar up to date. And then we just start the job. Now there's a status handler, and here's where we add all those little messages to show what's happening on the server side. But the key bit here is this completion handler. When that comes back, we get an offline result, and we're just going to close that download panel. What we do with the offline result is it ends up in here. We just take that map view that we had, and we take the offline map out of that result. So the result being passed in here is this bit here. We just take the offline map out of there and show it in the map view. That was the first demo where we got the base maps clipped to the area of interest. But if we wanted to override the area of interest a little bit, we just add a little bit of code here. So in this case, we're going to call an override to this function with a buffer amount, and that's described here. So all we do that's different is we generate offline map parameter overrides given the parameters. So we begin, as before, by generating parameters considering the area of interest using the offline task. And then we say, okay, now we've got those parameters, I'd like to override some of them. So please give me a set of overrides that I can modify. And what that comes back with is a really fine-grained set of parameters that will be used to take that whole map offline. Base map layers, operational layers, and so on. And we can go in and we can tweak any one of those settings that we need to. In this case, we want to tweak the setting for the base map layer. So we look at the online map and we just get the first base map layer in it. And we also calculate a buffered area of interest. So we had that initial area of interest that defines how the features are being clipped. We actually want to buffer by a bit more. So we get an override key by providing the base map. And we say for that override key, we want to update the area of interest to this modified, buffered, larger area of interest. So this bit of code here is just saying, for the base map layer, get a larger area. And then we just jump back into the code that we had before, and the only difference is that when we create the job, we use a different generate offline map job call that also accepts these overrides. So we have the default parameters that we had before. We also have the per layer overrides that we've tweaked, and it comes down to the same download location, and everything else is exactly the same. We get the same kind of job back, we hook it up to the UI the same way, we execute it the same way, and when we get the result back, we drop that into the map view exactly the same way. So that was getting a web map offline using its default settings for a given area of interest, and then taking a look at how you override individual settings for the contents of that web map if you need to tweak or change anything. Okay, so that was quite a lot to cover, but we saw how you can take an area of interest. Ultimately, it boils down to something very simple. You have your offline map task, which you initialize with an online connected web map. You set some default parameters. In this case, we use the area of interest that we wanted to download, and you generate this job. Then you start the job, monitor the job, wait for it to complete, and when it completes, it'll hand you an offline map. It's local on your device that you can just set to the map views map. Now, this is a key pattern in a lot of offline work with runtime, and actually is a key pattern throughout runtime with long-running processes. You can have a task, and the task is the thing that connects the runtime to the remote service. It has methods on it to create different kinds of jobs depending on what you want to do. So you set up parameters and you get a job from the task using the parameters. And then you simply start the job, monitor it, wait for it to finish, and then take suitable action. So we'll jump right back into another demo, this time looking at the pre-planned workflow. Remember, the on-demand workflow is very flexible, but places a load on the server. And you saw during that last demo that some of the downloads took quite a while. It took a while to prepare the vector tile packages. It took a while to prepare the geodatabases before they were able to download. Let's contrast that now with what happens in a pre-planned workflow. So I want to take a quick look at a couple of aspects of working with the pre-planned workflow. Here we are looking at the familiar web map again, and I'm going to jump into its description page. So we can go into the settings here and take a look at offline, and you can see, okay, we've got offline mode enabled again as before. We can see there are 5 map areas defined. So let's take a look at what that means. We'll click this button, up pops the Map Manage Areas interface. I'm just going to zoom in a little bit here so you can see, okay, we've got that same context. Here's the same data. It just happened to be out of scale range at that point. But we've got these 5 areas we've already defined. We can hover over them. We can take a look at one of them. Let's take a look at this Columbia States area. See, there's some little hints and tips here which we can dismiss. We've got some information about this area. How often does it update and when? When's the next update scheduled? So as data is changed in the map area, ArcGIS Online or Enterprise will go ahead and repackage that on this interval. We could edit this, delete it. Let's go ahead and create a new area. We'll do that and draw an area right up here. Let's call this Windscape Villages. Say how much detail we want on the maps. Now we've got a vector tile based map here, so we can zoom all the way in without worrying about generating too many tiles necessarily. Every week? Sure, every week. Well, let's do every day again at 5 a.m. And we'll save this. So now it's created that additional area for us. It's busy packaging it up initially. It'll do that the first time you create it. It's going to create that initial package, and then it'll revert back to the schedule. So let's look at that running on an iPad. Here I've got pre-planned application. It's pointing at that web map. You can see it's already picked up that Windscape Villages option. Now I'm not going to load that because it's still packaging right now. We can go ahead and use one of the other ones, like Columbia Estates. We'll tap on that, download it. It comes down over the wire really quickly, and we end up with this map, this fully interactive map with those vector tile base maps sitting behind our operational data. And as we've talked about, we can edit this, we can synchronize this back. But let's take a look at what code was involved there. So if I switch over to Xcode, first thing to think about is connecting to that map. So as we saw with the on-demand, it's pretty straightforward. It's very much like just showing the map in the display. In this case, we're not even going to bother putting that map into a map view. We're just going to create an offline map task based off that map, just as before. Now, when we display that user interface to list out the areas, here's what happens. I'm passing in the offline map task, and I'm just causing get pre-planned areas. When I've got them back, I've got an array that I'm holding onto of areas, and I just set it to the results that I got back from calling get pre-planned map areas up here. That triggers a user interface update. We're not going to look at in this bit of code. The key bit really is when someone picks one of those areas, what happens. So let's take a look here. Here we've got an area that was selected from that user interface that came out of this array of areas up here. We've got that same offline map task again, and we've figured out a location that we want to download that to on the device. We have control over that, so you as a developer can know where these things are being downloaded to. Using that offline map task, we call download pre-planned offline map job and get a job back. Now with the on-demand workflow, we specified a few things. Here we just specify the area and that download directory. We can add that observer again to watch the progress and keep the status bar updated. And then we just kick off the job. We call start. We get this status handler that gets updated whenever there's a new message to display or the job status has changed. And then we have a completion handler, which is called just once at the end when all the data has been downloaded and it's ready to open. So here we've got a result. We can set that result. And then what we do is we hide ourselves and show the map view. So we've got this result from the completion handler stored away. And very simply, back here in the map view, once we've hidden all the user interface and returned to the map view, we've got that ArcGIS download pre-planned offline map result. That's this thing up here. And we just say result.offline map, get that, and associate it, show it in the map view. Make the map views map that offline map we got back. And that's all it took to list the areas, download a specific area, and display the map representing that area in the runtime. Okay, so we saw that was pretty straightforward as well. The key bit there was defining your areas in ArcGIS Online or ArcGIS Enterprise ahead of time. And of course, you can do all that through Python as well. There are APIs for defining these areas and managing them too, but there's a user interface in ArcGIS Online. And once you have that user interface and you've got things defined, the approach is very similar to the on-demand flow. We create an offline map task pointing at that web map again, only this time instead of getting parameters with an area of interest, we list those predefined map areas and we get parameters for one of those map areas. At that point, we just create that job again. We start the job, wait for its result, set the map views map. So you can see how this pattern is starting to repeat itself. Just a quick note on the kinds of things that you can take offline if you've got a web map. If you've got vector tiles or bitmap tiles, raster tiles for your base maps, perhaps, then you can take those offline. They'll be packaged up automatically. If you've got feature layers that are enabled for offline, you can take those offline. If you have non-geographic tables in your web map, you can take those offline too. And relationships between features and tables are handled as well. Attachments also to features can be taken offline. And then feature collections, which are small amounts of geographic data that they don't have that feature service backend. They're embedded in the JSON of the web map. It's useful if you're doing some analysis and you get a result back and you just want to display that. You don't need to store it anywhere. You can actually keep that in the web map. So those are the kinds of things that a web map will automatically package up and bring download for you. So we talked about bringing maps down to the device. Now, how about updates? This is a key part of many workflows. Once a map is on the device, there could be updates to the source data that render the device's map out of date, or you could be doing edits on the local data on the device, and you need to share those back up to the source data, or both, the sync. Well, that's where your update strategy comes in. Remember at the very start we talked about, well, are you going to be always connected? In which case you can just edit directly against the service. You're going to be never connected, in which case your editing opportunities are slightly limited, but to get updates, you'll have to recreate the mobile map package from ArcGIS Pro and distribute that again. Now, if you get clever, you can do things that involve editing in this never connected workflow, but you have to write some custom code to do it, and you have to figure out exactly how you're going to transmit the data back and forth. Currently, a mobile map package that's been edited cannot then be pulled back into Pro to reconcile those edits. And then there's the sometimes connected approach, where you have network connectivity, you know that you're going to take a map offline because you might lose network connectivity, and there you deal with the mobile map offline. You edit the data locally, and you work with that offline map sync task to synchronize the data back. Now you have to think about when to sync. Do you wait until you know you're in a good area of network and automatically do it for your users, or do you ask your user to tap a button to sync themselves? Do you even do it from the field at all, or do you wait until they're back in the office or at the depot where they have Wi-Fi control to do this, Wi-Fi available to do those syncs? These are all questions you need to answer and need to understand, harkening back to the initial premise of needing to understand this as you're designing the app rather than bolting it on later. And when you do the sync, do you just want to get updates from the service, or do you want to push your edits back up, or do you want to do both? So just going over that again really quickly and covering some of the highlights. Remember that in the sometimes connected scenario, a map came from a web map, so the data came from the service, so you can edit. And you need to understand what you're going to be synchronizing, and remember that you have these overrides that give you layer by layer control. So if you have a map with 20 layers in it, and you only need to synchronize one layer's edits back up to the service and get an update from 2 layers from the service, you can arrange that with these overrides. Leave all the other layers exactly as they are. And this applies to on-demand and pre-planned. So let's jump into a quick sync edit demo and see synchronization at work. So I've created a web map here. It has some layers in. These are editable layers. And I could add items here. When we go and look at the web maps settings here, we can jump into the offline settings and see that I've created one offline map area. This map area is defined as this particular area of the map. Looks surprisingly like the bit we were just looking at. And I'll jump over to my iPad now and take a look at this map. So here I've got another demo. It's looking at that web map. It's found that one offline area, and I'm going to download it. Going ahead, talking to ArcGIS Online, getting that pre-packaged area down. My network here is not as fast as it could be with this webinar going. You can see it's still coming down fairly quickly. And once it comes down, I have a map on the device. We saw earlier with the pre-planned demos and the like that we had this interactive map. Here I've added some capability to add records to the map. Where I tap, it's going to add diving birds. You can see that sync button has enabled on the right-hand side. So I'm now going to synchronize this, and we'll see a little progress bar. So Runtime here is saying, oh, I've got some edits here. Let's package them up into a little Delta geodatabase that I'm going to send back up to the service. It does that. The service is going to look at whether there have been any edits on the service side, and generate a little packaged Delta geodatabase as well, and push that back down to the runtime. Once that's all completed, we'll have the runtime updated with any changes on the service. In this case, there weren't any since the map was packaged. But if we go back to the service now, and we refresh this map, we see these 3 additional entries that we added. So they were synchronized back up to the service based off that pre-planned map. So I downloaded a pre-planned map, did some edits, and synchronized back up. Let's take a quick look at the code behind that then. So here we started off with a map that came out of the pre-planned map package. We saw that earlier, how we get that. In this case, I'm sorry, this is the wrong code. Here we go. Here we go. So we've got the map that we create the online map. We created the offline task. We brought the data down, and then we set up so that when we tap, we create a feature. Here, when we're tapping on the map view, we go to that feature table that we got out of the downloaded map, and we create a new feature. Just so happens that type 2 means that diving bird, and we add it at the map point where we tapped. Then we call feature table.add with that feature. Now, this flow may seem a little incongruous. It's important to do it this way so that we can create a new record without inserting it into the database first, modify it, and then only put the final version that we're happy with into the database. So we add that bird to the feature table, and that's it. And then we update the UI. The UI will check to see if there are any edits available, and if so, it'll enable that sync button. When I click that sync button, here's what happened. I took that map sync task, which is connected to the remote web map, and I say I want default offline map sync parameters. It looks at all the layers in that map and figures out what's sync enabled, what isn't, and gives us back parameters. Those parameters are very straightforward. We don't modify them at all. We just hand them right back over to create an offline map sync job. And then, as we saw earlier, we just hit start on the job. It'll kick off the job. We saw the progress bar whirring away, and when it was finished, we were able to just look at the result. Now, in this case, we were already showing the map, so we didn't need to change anything. And we can, all we have to do is look for errors. There are two sets of errors. There's like an overriding error, which we handle here, like the network went away. And then for each record that we synchronized, there could have been an error writing to the database. Maybe it didn't pass some validation. Maybe the data store was having errors on the server side. It's important that we have a mechanism for interrogating that on the runtime should anything have gone wrong. And that's it. When we're finished, we pop up the alert. We saw that was pretty straightforward, though. We took the offline map sync task, created default parameters, and synced the offline map. Runtime took care of updating the map display and everything. Had additional records come down from the server. There weren't any in this case. We would have seen them. Now, every time you do a sync, it does involve work on the server, and that has an impact on scalability if you have a lot of users syncing. We saw how the pre-planned workflow handled the case where we were generating maps and pulling them down to the device and handling scalability there. What if we want to have a lot of users just needing to have updates from the server? They're not necessarily doing much editing themselves or any editing. They just need to see updates coming down. Well, that's a lot like the pre-planned pattern. And in fact, we call that scheduled updates, and it's an extension to the pre-planned workflow. So you create your pre-planned map as usual. On the server side, or using Python, you also schedule more frequent updates. Say we generate that map package once a day or once a week. We can say, oh, once an hour, I'd like to update I'd like to create little Delta packages, as would have happened in the on-demand sync. And I want to have them ready so that when a runtime app that's downloaded a pre-planned map says, bring me up to date, I can look at all these little deltas that have happened once an hour, perhaps, pull them all down to the runtime and add them appropriately. Runtime takes care of figuring out which deltas it needs to pull down. And it does this and applies them to the local database using the offline map sync task. This does preclude you doing editing on these bits of data because obviously we're generating deltas from the service to bring down. But for a lot of use cases, this works really, really well. It's one-way updates from the service to the app. So let's jump into that real quick and just see a quick demo of that in action. I'll jump over to the app again. Here we're looking at samples. There's a scheduled updates. You can see it's kind of hard to see, but at the bottom here is we've interrogated to see that there's 700,000 bytes of update available to map. And I am just going to tap on the Apply Updates button. And you can see how quickly we got changes down from the server and we're able to apply them to the map. Now we'll look at that other code that we were looking at before. And this is pretty straightforward. We have the pre-planned map already there. And we've got an offline sync task that we created from that map. All we do is we call check for updates and we get an info object back. That info object will tell us if, given the state of our offline map, there are additional updates available for us to download. If so, I just enable the UI. Once I click the Apply Updates button, I take that sync task again, I get the default map sync parameters. Much like with the other sync, don't really do much, but in this case, I do explicitly say I want to download all the updates for the scheduled updates that are available. Then I create a job and I start the job. And that's it. The runtime will take care of downloading the updates, updating the mobile map package. In this case, there is an extra step that we need to do where, although the local data has been updated, runtime tells us whether it was able to update the map explicitly or whether it needs us to go ahead and essentially reopen the map, which we're doing here. So we get that, we close the old mobile map package, reopen it, and then just put that into the map again as we had before. So let's jump back into slides. Very similar to the other sync operation, only we're now setting a single parameter to download updates. Okay, so that was quite a bit to cover. There are various other bits of offline goodness. Base map by reference. When you go into ArcGIS Online, you go into your offline settings. There was an option to some advanced settings, and in there you can give it the name of a TPK, a tile package, or a vector tile package, VTPK, that you know will be on your application device. And then when you take the runtime offline, if you remember when we did the on-demand area, it took a little while to generate the VTPK. If you know you've already got that on the device and you've got a base map that you can share, you can configure the web map to not download it. Runtime will take care of that and just use your local base map. You can also use non-ArcGIS local data files like a geopackage, a shapefile, KML, rasters, all locally stored on the device, and add them to your map. So even if you pull the map down from a pre-planned map, you can add layers based off these data sources. If you want to get really into the weeds, all of this stuff is built on APIs that work service by service. The runtime makes it very neat, as you can see from these APIs, but if you wanted to, you could bring your own set of vector tiles down from another service, add them to your map. Same with feature services. So you have great control if you need it. Runtime supports offline routing and directions and navigation API now. You can do service area and closest facility too, although those require a standard license. But routing and directions, if you've got the data on the device, can be done for free. And geocoding forward and reverse, as I mentioned. And as I've hinted, you can mix and match any and all of these. We have open source apps as well. There's an offline map book and a data collection application that demonstrate a lot of these principles. And remember that a lot of our COTS apps also use the runtime, like Collector and Navigator. I just want to jump back into the browser here really quickly and just show you how to find some of this stuff. So if you go to developers.arcgis.com and you jump up to the documentation, you'll see documentation for each of the runtimes here. We can look at the iOS one. I encourage you to look at the guide doc, which will include a lot of information that we've covered today, the API reference. We look at the sample code. We have some rich samples. You can download it from the App Store for iOS, but it's also available open source on GitHub. And if you scroll down here, you can see some of these open source apps, like the data collection app. This is also open source on GitHub, and we talk about how we built it, how it's designed to work with flexible schemas and so on. So these are great ways to learn and see in practice some best practices for working with these things. Okay, one last slide. We've been through all this. Just a summary of what we covered. You can get mobile map packages from ArcGIS Pro. There's no editing, but you do get geocoding and directions can be included in multiple maps. If you're hitting ArcGIS Online or ArcGIS Enterprise against a web map, you essentially get an exploded mobile map package on the device. You can do this on demand or pre-planned, understand the load on the server, and work with scheduled updates to bring updates down if you need to. You can do editing and syncing though. And you can work with local data files, you can mix and match all this stuff. Okay, thank you so much for your time. Thank you for watching. We have time, I guess, for a few questions. I'll hand back to Amy.
Thank you, Nick. We're now going to begin answering the questions submitted during today's presentation. We've received just a few, and we'll try to get through all of them. If we are not able to do so, we will make sure to address them in the GeoNet blog post after this webinar. As a reminder, you can still submit questions through the questions pane in your attendee control panel. So to begin, our first question is there a way to generate mobile map packages in ArcMap, or must I use ArcGIS Pro?
Right, so short answer is no. In ArcMap, you can't generate mobile map packages, but you can generate some of the components that go into an offline solution. So ArcMap allows you to generate individual geodatabases. So if you have features, if you have a feature database, geodatabase, you can create the .geodatabase that Runtime uses behind the scenes as part of this. So it does mean that you're looking at some different patterns, slightly different patterns. A couple of slides ago, I talked about being able to go service against service to pull services down. You end up working at that kind of level. So you can generate a TPK, you can generate a geodatabase, and then in the runtime, you can pull those together and create a map in the runtime and add them as layers to the map. But for ArcMap just doesn't really understand the central concept of the web map spec, and so we've been building that into Pro, and you really need Pro to generate these mobile map packages. But ArcMap can support you working offline. In addition, ArcMap can generate locators and network data sets that can be used offline as well. In Pro, those get packaged up into the mobile map package. Again, in ArcMap, they just get generated as separate entities, and you have to glue them together in the runtime.
All right, perfect. Thank you. Can you create mobile map packages from web maps that you create in the ArcGIS.com map viewer, either in Portal or on ArcGIS Online?
Mobile map packages themselves, no. But what's happening behind the scenes when, if you're prepared to do a little bit of code and digging on your device, if you use the offline map task, what it does is on the device, it generates a folder with the various components of a mobile map package. So you essentially end up with a mobile map package on the device. You just don't really know anything about it unless you go digging for it. So you could, at that point, if you really wanted to, you could zip that up without compression and you name it a .mmpk, and you would have yourself an MMPK file. It's important not to use compression when you're zipping it up. Now, it doesn't have all the features of an MMPK that comes out of Pro. For example, you won't have locators and network data sets in there, and you also will only have a single map, whereas MMPK, ArcGIS Pro can generate multiple maps with a single set of data behind them. But that way you could, if you really needed to generate an MMPK that way, you can. Yes.
All right, great. You showed some code during this webinar. Is it all shared somewhere?
Is it all shared somewhere? Good question. Some of it is, yes. Some of the code I used is in the samples app. Some of it is not, but I can be sure to share it and throw it up on GitHub and make sure that links to it are included with the follow-up email.
All right, perfect. And for our last question, must mobile map package areas always be rectangular, or can I use a polygon shape? For example, features clipped to a city, county, or state boundary?
Yes, indeed, you can use a polygon shape. That's something that was added a couple of releases ago. And obviously that can save you an immense amount of time if you're dealing with, say, the example I've seen is an Autobahn in Germany running from Hamburg down to Berlin, I think. And if you were just to get the envelope for that, it would be a huge amount of data. But if you just take a small buffer around the Autobahn, you end up clipping very, very efficiently. And in the pre-planned map area manager in ArcGIS Online, you can, in the demos we saw, they were all envelopes, but you can Instead, draw a polygon if you need to.
All right. Well, thank you, Nick, and thank you, everyone, for attending today's webinar, Building Offline Location-Based Apps with the ArcGIS Runtime SDKs. If you have any other questions, please feel free to contact me using my email address. Once you leave today's webinar, you will receive a survey on the presentation, and we would appreciate if you would complete that and provide your feedback. We will be providing a recording of this presentation, which will be available within 7 to 10 business days. It will be located on the go.esri.com/geodev page. And on behalf of Esri and our presenters, thank you for joining us today and have a great rest of your day.